Okay, today is St. Patrick's Day. It is Thursday, and we watched a video and talked a little bit about Pythagorean theorem some more and filled out our blue note. This is the blue note that's going to take us through our test tomorrow and the week after spring break, and we'll test on that Friday also. All right, first thing we talked about was what does a squared plus b squared equals c squared mean? What does it mean? Okay, this is a score 2. This will be one question on your test tomorrow. Before we do that, let's look up here a little bit. It says the theorem works both ways. All right, the main use of Pythagorean theorem is it says if a triangle is a right triangle, then this is true. A squared plus b squared equals c squared. So for any triangle that has a right angle, no matter what it looks like, as long as that you see something like this, and it has this in it, so you know it's a 90-degree angle, or if it says 90 degree, then you can be assured that you can take your A and B, your two legs, square them, add them together, and it will equal the square of C, the hypotenuse. Okay, that's what Pythagorean theorem is. The converse, I'm going to put it on here, converse to that is, well, if I have a triangle, I don't know if it's a right angle, but I have the 3 different measurements. If a squared plus b squared equals c squared, then I can say it is a right triangle. Okay, so there's 2 ways it works. So what does this mean? It means that if I have a right triangle, I know that I can square the legs, or you could put the 2 shortest sides, okay, either one would work, add them together, and it will equal the square of the hypotenuse. So if I have a right triangle, any right triangle, big or small, no matter what, I know that I can square the legs, or the 2 smaller sides, add them together, and they will equal the square of the hypotenuse, or the longest side. Okay, that's what a squared plus b squared equals c squared means. Okay, you've got to be able to write something like that. It doesn't have to be word for word, but I need to be able to read it and know that that's what you mean. Okay, so that's score 2. This is score 2. We'll go ahead and put here score 3. We won't look at this until next week. Well, after spring break. Okay, this is score 2. So this and this is what you have to do on the test tomorrow. I'm going to give you 3 numbers, or I might have a picture and have you draw, or have the numbers, have it labeled. So maybe here I have, this is my right angle. No, I don't know that it's a right angle, sorry. So I might have 8, 10, and 16. So I've got to decide or tell me, is this a right triangle? So I've got to use my formula, a squared plus b squared equals c squared, because it says if this is true, if a squared plus b squared equals c squared, then yes, it is a right triangle. So let's see. All right. So A, let's label this A, B, C. Oops, wrong way. This is C. It doesn't matter which one these are. Let's say 10 is A, so that'd be 10 squared. Let me just write that. 10 squared plus 8 squared equals c squared. 10 squared is 100, 8 squared is 64, c squared we don't know. Now the reason we don't add this and put 72 here is this is an equation. Our c's stay over here, our a, b stay over here, unless we move them and do the inverse. But we're not gonna have to do any of that yet. All right, so 100 plus 64 is 164 equals c squared. So would I put 164 here for my c? Oh, no, no, no. I'm sorry. I don't even know what I'm doing. Sorry. I forgot. We know it's C is 16, so this is 16 squared. I'm sorry. We're going to do a problem like this in a minute. All right, so 16 squared is 225. So, sorry about that. 164, does 164 equal 225? Really, I should put a question mark there. No. So since these are not equal, this is not a right triangle. Okay, I use my formula, a squared plus b squared equals c squared. A squared is 100, b squared, 8 is 64, c is 16, and that squared is 225. I add these together, and these do not equal each other, so it's not a right triangle. Okay, so you'll have a couple of these. You'll have this question. I might also have a diagram for you to label. Okay, we know that when I have a diagram, it says label the legs and the hypotenuse. The hypotenuse is always the diagonal. But what if I drew it like this? Well, let me see. What if I drew it like, when I draw it like that, it's hard to see what's the diagonal, because now these two look diagonal. But if I know that this is my right angle, then I can see the true diagonal is here. And the other thing we know about right triangles is the hypotenuse is always across, directly across from the right angle. The legs touch the right angle, kind of like the legs hold up a table. The hypotenuse is going to be directly across. So once I see my square, this is my hypotenuse. Isn't it fun just saying that word? These are my legs. Then if I wanted to label the A, B, and C, hypotenuse is always C. Legs, it doesn't matter. This could be A, this could be B. I could put B here, A here. They're interchangeable. C always has to be hypotenuse. All right? Now, the theory only works with right triangles. All right, let's look up here. The Pythagorean theorem is for finding missing links. And we're going to see a little bit more about some of those ideas next week when we start doing word problems, some real world applications for missing links of triangles, of right triangles. Because that first reason for Pythagorean or definition is if a triangle is a right triangle, then A plus B equals C squared. So if I only have A and B, I can find C squared. If I only have B and C, I can find A. Okay, it's an equation that we'll have to work with. So, but the main purpose is finding the missing link. The other purpose would be to determine if three numbers are actually form a right triangle. Okay, now we're done with score 2. If you want to go color these like it says you can. Oh, Pythagoras. We said he's an old Greek dude, okay, that discovered Pythagorean theorem. And his students, I'm sure, helped too. All right, here we go. Now, this is our first score 3. Okay, so this is a score 3. Okay, this is a score 3. Everything else is score 3, except for here. The theorem is actually A squared plus B squared plus C. Here's what each letter represents. So A represents the legs. B represents a leg. C represents the hypotenuse. Every time. All right, now let's go to our score 3. This is score 3. We're only going to do one today. When we come back tomorrow after our test, we're going to practice some more. So this tells us a right isosceles triangle has legs 6 meters long. So I know that isosceles means that these two sides are the same length. Okay, but it doesn't tell me C. I only know A and B. Okay, so I'm going to put A squared plus B squared equals C squared. Okay, and if you ever see a triangle, it may not even, sometimes it could be different, but maybe it's E, F, G. If it's a right triangle, that's the same as ABC, okay? Doesn't always say ABC. So I know that A is 6, because B is also 6. All right, so this is going to be 36 plus 36 equals C2. This is where I was getting confused. This is your equation, and this is where you draw a line down the equal sign. We keep our C's over here, our A's and B's over here. So I wouldn't have written 36 plus 36 equals 72. Okay, 72 goes here, equals C squared, and we don't know C squared. Okay, so do I put 72 right here? Would my sides be 6, 6, and 72? No, because 72 is C squared. I just need C. What do we do to get the square root of C squared? What letter are we multiplying together 2 times to get C squared? We're getting C. So I took the square root of C squared, so I need to take the square root of 72 because that's the inverse of squaring a number. Now 72 is not one of the perfect square roots that we know. What are the 2 closest? Okay, I know that the square root of 8 is the square root of 64, and 9 is the square root of 81, and 72 would be somewhere around in the middle. So I could estimate it to be about 7.5 maybe. What if I was looking for the square root of 68? Sorry, that's supposed to be 8. In between 8 and 9. 8.5. That would be a little closer to 8, wouldn't it? So that might be maybe 8.2 or 3 maybe. Or what if I was looking for the square root of 78? That's closer to 9. So it may be like 8.8 or 8.9. So sometimes it might ask us to estimate the square root. Maybe if it was on a test where you didn't have access to a computer, they might tell you to estimate. So you just find the perfect squares you know and see whereabouts they are in between. Okay? But this one says, find the length of the hypotenuse to the nearest tenth of a meter. All right? Nearest tenth of a meter. So we're going to have to actually find the square root, and it's going to be a decimal. Go get me a calculator. All right, so on these little white calculators, which we will have during ACAP, and you'll also have the Desmos calculator, which will be a lot easier to use to find square root. But on this one, we see that there's a little radical right here, but it's a light number, it's not white. So we have to use the shift button. See how the shift button's the same color as the radical? So what we would do is we would put in 72, shift, and the radical sign, and it pops up this number, 8.485, and I can stop there because it tells me to round to the 10th. So the 10th would be this place. This is the hundredth, this is the thousands. Okay? So 8 tells me to round that 4 up to a 5, so my answer would be 8.5. And look, that's what we guessed. That was our estimation on this sheet. Okay, another way sometimes they'll tell you to leave it when it's not a perfect square root is just leave it as in the radical form. Just leave it under the radical. And that's the funnest because you don't have to do any more work after that. Okay, now so sometimes your right triangles will work out where you have a perfect square root and you'll have a whole number. Okay, like we've already learned that 3, 4, and 5 all do form a right triangle, and we call this a triple, a Pythagorean triple, because the sides are all whole numbers. But for this one, we have 6, 6, and 8.5 or the square root of 72, okay, that's not a integer. It's not a rational number. It's not a rational number. It's not a whole number, okay? When we have three that are whole numbers and they do follow the Pythagorean theorem, we call them a triple. Another triple we learned the other day was 5, 10, and 13, because 5 and 10 is 12. 144 equal the square root of 13. So we already know two triples, 3, 4, and 5, 5, 12, and 13. All right? You don't have to memorize any triples, but just know what that word means. All right, so we just found out that we can use this formula now to find a missing side. Okay, this time we were missing the C. Sometimes we're going to miss B. Sometimes we're going to be missing A. And we'll work on some of those tomorrow.